Okay, want to review some old things related to graphing logarithms. So first of all, this is not a logarithm. This is the standard graph of an exponential function, like y equals a to the x when at least when the base is a number bigger than one. So this is your picture of like like y equals 2 to the x, or y equals 3 to the x, or y equals e to the x, or y equals 25 to the x. They all look like this. They're all slightly different, but they all have this shape to them, have a y-intercept of 1. If you flip this diagonally, you'll get this picture here, where now the x-intercept is 1. This is the graph of log base 2 of x, or basically slightly different would be log base 3 of x, or log base 4 of x. But they all look like this. They all have a little piece that starts in the fourth quadrant, cross the x-axis right at 1, and then the rest of the pictures in the first quadrant, and is rather a shallow picture like this. Okay, so this is an exponential functions graph. This is a logarithm functions graph. Just to review some things, the domain of the exponential function is negative infinity to infinity, so that happens to be the range of the logarithm. Okay, the range of the exponential function is 0 to infinity, excluding 0. That's why the domain, remember, these are inverses, so range of one is the domain of the other. That's why the domain of the logarithm function is 0 to infinity. This domain of the log function being 0 to infinity has come up in so many ways, right? It came up in needing to check solutions of an equation to make sure that the x value causes the input to log to be positive. It came up when finding domains of functions which involve logarithms. It's come up in quite a number of different ways. This exponential function had 1 as a y-intercept, so the inverse has 1 as an x-intercept. This exponential function had no x-intercept. I know it looks like there is one, but the graph just gets closer to the x-axis. So if there's no x-intercept here, then there's no y-intercept there in the logarithm function. And then this function here has the x-axis as an asymptote, horizontal asymptote. So then the logarithm function has the y-axis as an asymptote. Now we mention all these things because these are two different functions, a to the x versus log base a of x. But let's take this logarithm function and talk about doing a graph transformation. So how do we graph y equals log base 3 of x plus 8? Well, first, as like a main function or a primary function, like a base function, think about f of x equals log base 3 of x. So that looks like the type of function we just saw, right? That y equals log base 3 of x would be the type of function we just saw in the picture on the right. And then the thing we're asked to graph here is y equals f of x plus 8. But think about what that plus 8 does, right? Notice it's in parentheses. This is a horizontal thing. Remember all the horizontal things? What that plus 8 does? This is a shift to the left by 8 units. So if this here is the graph of y equals f of x, where f of x is log base 3 of x, then if we shift this picture, just the points in blue, to the left by 8 units, we get a graph that looks like this.